A setback in using Newton-Raphson method is the difficulty of differentiating the function. But as long as the derivative is right, root finding is still easy. Welcome to Numerical Solutions to CE Problems. Saying that it is classified as an open method, Newton-Raphson only needs a single point to start with. With a given function, say that the initial value has been identified, with x distance of x0 and y distance of f of x0. Newton-Raphson uses the tangent line to get close to the real root. The slope of the tangent line derives the function for the method. Slope is rise over run, which is then taken from the illustration as f of x0 all over x0 minus x1. Slope is also taken as the differential of the function, written as f prime of x. And when cross-multiplied, x0 less x1 then is equal to f of x0 upon f prime of x0. Since we are looking for x1, transpose terms to have x1 is equal to x0 less the function of x0 upon f prime of x0. So in a nutshell, the procedure of Newton-Raphson is through differentiation. The problem this time is a trigonometric function of x cubed with cosine of x less 2x minus 9. This time, we are to work on the negative root nearest the origin, and the standard of 4 decimal accuracy and whole number as initial values still prevail. So start by determining the initial values for the iteration. Since we are to look for 1 nearest the origin, we start with x of 0, making the function 0 cubed with cosine of 0 less twice of 0 minus 9, and this is negative 9. Next is to use x of negative 1, where the function then becomes negative 7.540302. Still a negative, so we keep on assuming. Next is negative 2, and we have negative 1.670825, another negative result, but nearing 0. How about trying negative 3 this time? The function is then negative 3 cubed times cosine of negative 3 minus twice of negative 3 minus 9, which gives 23.729797. At last, we found the sign jump. We know now that the root lies between negative 2 and negative 3. The next is to take the average of these two values. So x0 is then half of the summation of negative 2 and negative 3, and that is negative 2.5. Knowing the first value of x, we can then continue with the f of x, which becomes the cube of negative 2.5 times cosine of negative 2.5 minus 2 times negative 2.5 minus 9. And this gives 8.517869. The next parameter is for f prime of x. So we then differentiate the function. F of x is x cubed cosine of x minus 2x minus 9. The first term requires the product rule. So f prime of x starts with the first term x cubed times the derivative of the second term, cosine of x. Then add the second term times the derivative of the first term, x cubed. Then, the derivative of 2x is 2, with the derivative of negative 9 as 0. We further simplify the d's, so there is x cubed times negative sine of x with d over dx. Applying the chain rule. The second term has cosine of x with the derivative of x cubed, which is 3x squared, times the derivative of x with respect to x. And then copy minus 2. d of x with respect to x is 1. So the simplified f prime is 3x squared with cosine of x minus x cubed times sine of x minus 2. With the prerequisites already laid out, we create the table for iteration with f of x and f prime of x. The first x is negative 2.5. Then f of this x value is 8.517869 as computed earlier. F prime of 2.5 is 3 times negative 2.5 squared times cosine of negative 2.5 less negative 2.5 cubed with sine of negative 2.5 and then less 2. F prime is then negative 26.37257. Let's then start the iteration. Solve for x from the Newton-Raphson function. So x2 is solved as negative 2.5 less the ratio of 8.517869 and negative 26.37257. This gives negative 2.177018. This value is what we plugged into the f functions. So f of x becomes negative 2.177018 cubed times cosine of negative 2.177018 minus twice of negative 2.177018 minus 9, which is simplified as 1.232758. Plugging in the same x value into f prime of x, we get negative 18.580283. Note the big difference of f of x from 8.5 to 1.2. So we are near the root at the second iteration. x3 is then computed as negative 2.177018 less 1.232758 over negative 18.580283, which is negative 2.11067. Use this value into f of x and get 0.054681. Then place it into f prime 2 to have negative 16.935413. For the next row, use values from the third iteration. x4 is then negative 2.11067 minus 0.054681 over negative 16.935413, which is simplified as negative 2.107441. Use this value in computing f of x, which then becomes 0.000125. Then, when x4 is also plugged in f prime, the outcome is negative 16.856002. Following 4 decimal accuracy, the root is negative 2.107441. But then, let us iterate further to check on the convergence. x5 is negative 2.107441 less 0.000125 over negative 16.856002. x5 is negative 2.107434. Using this value into the function of x, we get 0.0000007. And also, placing this value into f prime of x, we get negative 16.85583. We are so much closer to 0 with the current f of x. Although f of x is so close to 0, we are looking for convergence. So we iterate again. where x6 is negative 2.107434 less 0.000007 over negative 16.85583. Again, the term we use to subtract is practically 0, so x6 is negative 2.107434 just the same. This means that f of x will still be 0.00007 and f prime of x as negative 16.85583. So with no change in the values, we already reached convergence, and the root is at x of negative 2.107434.